Good evening. Am I audible?
Yeah, good evening. You're audible.
Is my screen visible?
Yes, your screen is visible.
Okay. So we can start firstly with the installation. So we need Anaconda to run our code. Basically, Anaconda is a free and open source distribution for Python and R, and it provides several tools like Jupyter and Spider wherein that we can use. Okay, so for Anaconda installation, you can search Anaconda Python and then go to the anaconda.com site. Here, okay, then just click the first link and then you can select the download for Windows, Apple or Ubuntu. ठीक है? Then you have, then according to your system you can download it. So I think I have already downloaded. I have downloaded this for my Windows system. Then you can click on it and run the exe file. Like next, you agree, then just me. Then this is the location where your file will be stored. Then next, since it is already installed in my system, therefore it is giving this. Now once this is completed, once this is completed, you will see in your all apps an Anaconda 3 folder will be created. Herein you will have Anaconda prompt, PowerShell, notebook and all these systems. Then you can go to Anaconda prompt. If you want to change your settings, then you can go here, properties. If you want to change the font size, so that way you can change. And first we will see the Python version installed with the Anaconda package. So it is Python 3.9.7, and then you can also check for the Conda. The Conda version that in my system is 4.10.3. Basically, Conda is your open source cross-platform package environment system, just like pip, and you can use it to install other libraries. Now, first thing, we can create an environment that will have all your libraries. The command for that is, suppose conda create my name of the environment. Suppose it will be environment 1. Then you can activate your environment. Your initially you were in the base environment. Now that environment is created. Now you are in that the environment that you have just created. Now you can make your installation. For example, let's install NumPy.
Why do we need to change the environment?
Basically, the use for environment is like, suppose I have different suppose my needs are different, like I am working on several projects and certain projects require certain libraries or certain versions of a library. So in that way I have basically created different environments. So in my each environment I will have, suppose in my environment 1 I have NumPy version 1, in my environment 2 I have NumPy version 2. So this way it will not create conflict. So if I want to create a project that requires this version of it, so actually it basically helps in better management. You
Okay,
can
got
even
it.
have
Thank you.
like, in your one environment you can have PyTorch, in another you can have TensorFlow, so that way you can also have. Okay. Once you have your Anaconda installed, then you need CUDA toolkit also, so that you can use your GPU. For that, you will go to this CUDA toolkit. You can simply search CUDA toolkit.
But if our laptop does not have GPU, then this would be useless.
So if you that would be useless. This is for those who have a GPU. Then you can go to downloads and downloads. Then CUDA toolkit download. Okay. Once you go there, according to your system, you can download it. Now, after that, you also need a CUDNN library. Okay. So,
Hello, Vasudha, am I
sure.
audible?
Yes, yes.
Yeah, like currently, like we are seeing like the process, but then afterwards we also need to install it on our system. So can we just record this meeting? Then we
Uh,
can gradually follow the steps you are doing here and then install it on
Actually,
our system.
meeting is being recorded.
It's recorded. Yes.
Okay, thank you.
Hmm. So, like, if this is done, then after that you need to download CUDNN also. So basically, you will again search for CUDNN. You will download the CUDNN that will be based on your version of the CUDA toolkit. Okay. Then I agree, and then you can download the version of it. So this will be downloaded in a zipped file will be downloaded. So that zipped file you can extract in your system. For example, like I have extracted in this folder. Okay, this CUDA. In this I have in my program files I have created this, and I have extracted that file over here. So once it is done, then you will go to your environment variables and you will set the path of it. basically you need to set the path of your bin, your library, and also your include. Okay. Once this is done, your setup is complete, and then you have to download your Visual Studio also, and after that your entire process is then completed. Now this is for someone who had, okay, now once you have done all this CUDA toolkit and CUDNN installation, now you have to install your PyTorch. Okay, so for that you go to the pytorch.org, and then according to your system settings, you can have stable, if your operating system is Linux, then Linux, or Windows, then Windows, then Conda, Python, and whatever version of CUDA that you have, and that you can select, and you can copy this and run in your Anaconda command prompt. This is one way. The second way is, suppose you have several libraries to install, and at times version conflict happens. So what I found very useful is that I create a text file with an extension YML. So I create a YML file, and in this I give the name. In this way I create it. Okay, so name basically depicts your environment name. So one is project. Okay, and then these are the channels. Actually, basically when it will download these NumPy, Pandas, Matplotlib, all these files, then from where? So these are basically the channels. Basically you have Conda, Forge, PyTorch, and then defaults also. So default is basically Conda. Okay, so in this way you can create a YML file, and you can write your all the libraries that you need. So for my project I need NumPy, Pandas, Matplotlib, and all these I need. And since I have an PyTorch version, this PyTorch version basically I have written according to my CUDA toolkit version. Okay, so only that I have specified. Now according to this version of my PyTorch, all the compatible versions for others are downloaded, and this is created, and all this is downloaded. So I can edit this file and NumPy, Matplotlib. I remove all
Have
this.
you
Okay,
typed?
sorry.
I'm asking, where have you typed all this manually?
This I have typed actually. Actually, like when I was this method that I told you, you can like here you can even install using this command. Like when you go to pytorch.org and you get this you get this page, then according to your system specification you can set, and you will get this command. But sometimes, like when you have many libraries to install, at times version incompatibility happens. So in this way, if you do in this way, then all that is taken care of during the installation. So basically you create a text file with an extension .yml. PyTorch, like I have created PyTorch underscore environment.yml file, and then this is the name. This is basically the name of the environment. Okay, then these are the channels, like from where it will install.
So, Bushudha, can I just intervene? Can you give a little bit of time so that the most of the people have installed Conda?
Okay, ma'am.
So today, everything they may not be able to install. You put them in a document so that they can do it slowly, but at least let them do Conda and some basic things. They may not be doing CUDA immediately, but the basic things like NumPy, Python, etc., so that you can get started. So give a little bit of time.
Okay.
So today we can just spend on the installation also if there's not enough time.
Okay. So once once you have created installed Anaconda and all these CUDNN and CUDA toolkit, after that you can you can go to pytorch.org for installing PyTorch, and you can select these settings. Like if you have Linux, then according to that, Conda Python version. If you have CUDA 11.7, then according to that, and this will change, and you can copy this and paste over here. Okay, and as you press enter, then it will be installed. Another and most effective way that I find is through this text file actually. So with this, like once you have created this text file, it will just NumPy and pandas. I can try. Like I'm installing just NumPy and pandas, and I will now execute this command. Before that, you have to be first you have like this, you have to be in this folder where your .yml file is present. Like mine is present in users in this location. Okay, users, so you have to go there, and here it is saved, this YML file. And after that, now this will install the files that I added. Now since this will take time, so another method, if you do not have GPU in your system, then you can make use of Google Colab. Okay, Google Colab is basically an online Jupyter notebook that allows us to run our code on the Google server. For this, we don't need to have a GPU or anything. We just need a Google account. So with Google account, this Google Colab, it is open. Now here we can either create from here, or this will save our files in our Google Drive. Okay. So here, like I have created a folder. Now this will have, so in this I can create a new collaboratory notebook. Okay. So this is basically a Jupyter notebook. So here we can make our settings. In this hardware accelerator, we will select GPU or TPU. Basically, we need only GPU. So we'll select that. This is one way. Okay, another way is through runtime also we can change runtime. So here we can run our code, and basically we don't need to do much installations here. It already has a PyTorch. For example, if I write import torch, this is all the installations have been done. Now we can check whether our environment is created or not. So in this, like, we gave the name project trial environment name, so we can say that, see that project trial is created. Okay, now I will activate project trial. Sorry. Now our environment has become project trial. In this we have installed NumPy and Pandas, so we can check it. Import NumPy as NP. This we are able to execute this since because NumPy is installed in this environment project trial. Now we can create any NumPy array, np dot once, then print x. It has created a NumPy nd array of 2. So this is one way. Okay, now if you do not have CUDA or GPU in your system, then you can use Google Colaboratory. Now anything in PyTorch, basically it deals with tensors. Tensors are our arrays, multi-dimensional arrays. So like if we have a 1D, then it is an array, 2D is a matrix, and more than 2 it is a tensor. But in PyTorch everything is tensor. So we have imported it, executed it. Now also now we can go to the execution. Now we can create a simple tensor in PyTorch. One way is torch.empty. It basically gives us a tensor of size, whatever size that we will pass it as an argument. Suppose I give argument as 4, then it returns a tensor of size 4. Okay, it basically returns an uninitialized tensor. Now we can check the data type of it. By default it is float 32. We can create with any data type, like for example torch dot int or double. We can even have more than one D array, sorry, tensor. Okay. Now another way is to create, we can even create using a random function. This basically returns a tensor which is filled with random numbers from the normal distribution. For example, like 4 x.
Does torch.empty also return a random tensor, as we've seen right now?
Empty also returns a random random tensor, but in this, like this will give you a random numbers in the from a uniform distribution, which between 0 to 1. Okay. Random will give you random numbers from a uniform distribution, and you can also have random n. This will give you from a normal distribution with mean 0 and standard deviation 1. Then you can even have random int. This will give you integer values. You have to even specify the size of it. Size for this, like basically random integer, like it takes as low, like suppose this is 4, so 4 basically it tells you the highest number. Like for example, this is 4, it basically takes low, by default it is 0, and high, as I have given 4 in this. So basically it will give values between 0 to 4, and this 3, it determines the size of the this. Now suppose if I change this to 2, 2, so it will give a 2, 2 tensor having values between 0 and 4. Okay, you can even specify the low range for this. Then it will give values between, now this will give between 1 to 4. Okay, then we can also create a tensor using,
If you write 2 comma empty, then what does it return? I mean,
to where
torch.randint 1 comma 4 in, then in brackets 2 comma, if I just don't mention the second argument.
if you don't
2
mention, then it will take it as a 1D.
Okay.
Then you don't need to specify this. it will give you a 1D if you do not specify the second one. Okay. Now basically you have linspace. What it does is, like, suppose I give you a lower range, say 3, and a higher range 10, and a step of say 5. So what it will do is, like, it will return the tensor now this will return the tensor, should be steps. So what it does is, it basically give you a tensor having, like, suppose 3 to 10. It will start from 3, and then it will like low minus high minus this. 10 minus 3 is 7, divided by, like, 5, it will give you 5, and these are equally spaced. It will return 5 equally spaced tensor whose value lies between 3 to 10, and the space between them is basically 10 minus 3 is 7, 7 divided by 4, that means step minus 5. Step minus 5. So it will be 7 by 4. 7 by 4 is basically it returns in the interval starting from 3. Then the second value will be 3 plus your higher 10 minus 3 divided by step, that is 5 minus 1, that is 4. Okay, so basically in this interval it will return you the values. So it will be 7 by 4 is 1.75. So it is returning in this way, 4.75 plus 1.75 plus 1. So you can see the difference between these. So these are it gives you you can say evenly spaced tensor. Okay. Then we come to the basic operations that we can perform using these tensors. So one is like, suppose simple addition. You create a random tensor x and you create a random tensor y. Now you can add these. You create another x plus y. This will basically give you the addition of x and y. It will perform element-wise sum, like 0.3141 with 0.2625. So 5 plus 1 6. So it gives element-wise sum. Okay, one method is this. Second method is like you can also use an add function of torch. Okay, so one way is this. Now second is you can even perform it in place. For example, you have torch, this add underscore x. Now what it will do is, in these two cases, it is creating another tensor z1 and z2. Now in this one, we are modifying y. This add underscore x. It is an in-place addition. So y is modified. Here the y was this. Now it is modified. So in Python, in PyTorch, every function with this underscore, it performs an in-place operation. Okay, then you can have other operations on this, like multiplication x into y. This will also perform multiplication, element wise multiplication basically. Then same you can also have okay. Now we can go to the indexing operation. Basically slicing operators. Suppose you create a tensor of size say 5, 3. Index after that you are slicing it, meaning this means that it will have all the columns, all the rows and just single column, zeroth column basically. So all the rows of the zeroth column. Now if I write 0, this specifies of the zeroth row all the columns, basically all the columns are included, or else you can use 0. Now this is 0 and 1. Of zeroth column, it is including all the element of the first 0 and 1, excluding 2. Okay. Then we can also access a single element. One comma 1. This is 0 1 0 1. Okay. Then now as you can see that if you're printing this, then it is having a tensor. You can also get just a single value of it with item function. It will just give you the value, the complete value. Okay. Now we can also change the view of this. Like This is 5,3. Now I reshape this to 3,5. And if I look into the size of it, it is reshaped to 3,5. This was 5,3. Now we have changed the view of it. Now suppose if you don't want to this -1 operator is like, suppose if we don't want to put a number in a dimension, then we can simply put -1. So what PyTorch does is it automatically determines the size of it. Okay.
-1 means what?
Like in earlier, like when I was using this 3,5, so it was reshaping this 5,3 to 3,5. Now suppose I don't want to know the first, suppose I don't know the first dimension, but I know the second dimension of a particular tensor. So according to the second dimension, the view of this tensor will be decided. For example, like here I have not mentioned anything. Another, like suppose I take a tensor of size 4,4. Okay. Now I reshape it to suppose I don't know the first dimension or the second dimension, 2, -1. So like 4,4, there were 16 elements in this tensor. Now it will have 2 rows. So according to the 2 rows, the remaining it has adjusted into the column 8 automatically, even without us specifying the dimensions of it. This comes in use when you do not know the second dimension actually. Like if during your program execution, this you know only one dimension, but you do not know another dimension is changing. So you can use this. You can keep -1, whatever will be the size of the x, it will change it automatically. So you don't need to specify it. -1 basically like if you do not know any particular dimension, you can write -1. This view command will take care of it based on the other dimensions. Okay. Now suppose you can also create your torch tensor using NumPy ND array. For example, you have first we'll see we have created a tensor of ones. Okay. Now using this command a.numpy, this will convert a tensor to NumPy. It is of class NumPy nd.array. Now, like in this one, suppose we have created a tensor A, and we have not specified. It is stored in CPU. Okay, so it can convert only those tensors NumPy which are present in CPU. Okay, and suppose now in this, like both A and B, they refer to the same memory location. It has not created a different memory location for B. Now suppose if I change this. Now suppose if I change the value of, say, B and print A. Then you can see that we have changed the value of B, but when we are printing this tensor A, it is getting updated. Why? Because since both are in the CPU, A and B refer to the same memory location. So while performing any such computation, we have to make sure, we have to keep this in mind. And suppose we shift the location of this tensor A to GPU. Okay, like presently if we see the location of this, it will give CPU and it will give false. False meaning that it is not in GPU. eSCUDA is false. Now suppose I change this to CUDA if CUDA is underscore available. This basically tells whether CUDA is available or not in the system. If CUDA is available, then this will return true, otherwise it will return false. Then else, if I will print device, it will give CUDA. Right, now I'm changing the location of A to CUDA. Now this will be true. Okay, now if I try to create the NumPy array from this, then so you cannot convert a tensor to a NumPy if it is in GPU. Since NumPy is only for CPU, that is why we need tensors, torch. Now second thing is, suppose you have this you have created a top variable and you can basically requires grad. What it does is, it by default this parameter, this argument is false. Now if you set this to true, it will tell the PyTorch that this parameter, this variable actually will be used in gradient computation, and gradient computation is very important in deep learning. Okay. What it does is basically, like, I have created this x, and if I will print this x now, it will give requires grad as true. Okay, so this actually tells the PyTorch that this variable will be used in gradient computation. Like there will be some function whose derivative we'll find with respect to this variable, and actually PyTorch basically it forms a computation graph that actually keep track of all the functions that are performed on this particular variable x. ठीक है? For example, suppose we perform an operation into b. ठीक है? Suppose this is a function and we have a as 10, value of a as 10 and value of b as 20. Okay, now if I will compute the differentiation of x with respect to a, then it will give me as b, and the value of b is 20. Okay, and differentiation of f with respect to b will be a, which is equals to 10. Now if we implement this in PyTorch, so first we will create a tensor a having requires with a value 10 and requires grad as true, and b tensor having value 20 and requires grad as true. Now the PyTorch will keep track of all the functions that are being performed on these two variables. Now I am multiplying these two variables. Okay, now this backward, it actually computes, backward function actually computes your differentiation with respect to your variables. Now if we want to access this, the gradient, grad function, grad attribute is there, grad attribute of a tensor that will give you the value of the gradient. Sorry, it needs only floating point actually. So as you can see that a dot grad, which was del f with respect to f with respect to a is b. Here del f a grad will give you del f with respect to del a, value of that, which is b 20, and df with respect to db as 10. Now suppose I change this to a, now these are just scalar values. Okay, now I change this to a vector. Okay, in place of this I'm changing this to a vector. Now when sorry, now when you will execute this, it will say that this backward function, it implicitly assumes that the output will be a scalar value. Like in this earlier, like we were when we were giving the scalar this single scalar input, then we were getting only a single value. So it implicitly it expects that this final f value is a scalar value. This f computation is a scalar value. But suppose we have to find the differentiation with respect to a vector. For that we need to pass the gradient. And this gradient should have the same dimension as this f. Then you can see that we are able to compute it. But this basically is when these were just scalars, default value for this tensor, this gradient is this. Even if this is the default value. Mm, Actually, you don't need to pass this. The default value of this is basically that, but it is giving error. Hmm. Default is this actually. So even if we do not give that single, even for the scalar values, even if we do not give past this, it is computing. But we don't need to learn this computation for vectors, because in deep learning, ultimately we compute a single loss function. We get a single loss function. So therefore, we don't need to learn this. Actually, this, I mean, not we don't get to use this thing. We never have to compute the differentiation of a vector with respect to the variable, because in the end we compute a single loss value. So it just works fine with this variable, with this, just the back.
F dot backward with arguments 1, 1 means what?
Sorry.
I'm asking F dot backward. Right now, you've given the arguments gradient is equal to 1, 1. What does it mean?
Basically, PyTorch actually it computes the Jacobian matrix, and it returns the product of a vector, which is basically the gradient, and the Jacobian matrix. Jacobian matrix is basically your partial derivative with respect to the input variables. So it is a matrix, and that gets multiplied with the vector, and which vector it is, it that one that we were passing through this. So basically it multiplies this gradient with that Jacobian matrix. So that is why we need to pass this as an argument.
Ma'am, what is gradient?
Gradient actually it is like function. It is this f a into b. So it is basically computing. It is basically telling you the impact of the variables a and b. Like with what, like with a change in a, what change, how much f will change. So that is basically what df by dA actually. Differentiation of f with respect to a, and differentiation of f with respect to b. And this actually we need a lot in deep learning, gradient computation and all.
So it multiplies the gradient with 1, 1, is it?
In case when your f, that is your output, is a vector, if it is a scalar quantity, like usually that what we do in deep learning, if it is that, for example, like we have, say, a function a plus 2, okay, then we are performing some activities on it, then we are computing the square of it and multiplying it with 2, and then we are computing a mean. So mean will be a single value. So usually this will return a single value. Now if we compute z with respect to this, now what it actually is doing is, like when we have defined this tensor and requires grad as true, it is creating a computation graph. So what kind of computation graph it is creating? Like first, and basically PyTorch, why it creates a computation graph? Because we know that later on we will need to find the derivative, the of with respect to this variable. So what kind of computation it is creating? Like for example, input a is coming, then we are adding it with 2, then after that y is then getting multiplied, and all this happening, and this z, it is a mean value, it is a single scalar value. So this kind of computation only we are required to, where we basically do it with respect to the loss. So loss is a scalar quantity, so we can just do backward without passing the gradient, and it will compute, it will give the gradient of the entire to us. And this is how we do this. Z backward actually we use in training and all.
Is z dot backward calculating partial derivatives with respect to y?
Yes. No, it is with respect to a.
Okay.
Z with respect to a. It is basically like del z, z with respect to y, then y with respect to a. So all that it is computing, and it is storing in this grad attribute. This grad attribute, it is storing the gradient that it has computed, and that we are accessing through this. And that's it. And if like suppose in this collaboratory, if you want to, suppose you have a data set, and if you want to access the data set, how you can do, in deep learning, like you need to work with the data set. So for that, you, to access that in Colab, first you upload it into your drive. Suppose this is the data set, and then you connect it using these lines, you connect it with your Google Drive. This basically connects with your drive, and after that, once it is connected, you can navigate through this present working directory. Okay, it asks for the permission actually that you have to allow, and then you can navigate to your then here, like this is the file actually, so this is the path, content, drive, my drive. Here you can see you are reached to my drive, then VQA dataset. Underneath this, you are going to train set. Basically, you are giving the path, just like in your normal system that you do. The same way you mention your file name like this. Okay, but first you have to connect with your Google Drive that you in which you have stored your dataset. That's it for today. Any question?
We can't copy the path from somewhere.
Which path?
Any file in the Google Drive.
Like you are getting the path in this way, like inside VQA. Sorry, in your My Drive, it is
Manually
this.
type it. I mean,
That you have to type. Manually you have to type.
Excuse me. For getting the path, no, there is a in the collab there is a folder sign, right? Can you please go there? Fold down. The folder sign is there in the Google Collab.
Acha.
There is a folder sign. There is search option down folder. Not there, not there. X is written, right? X after that. Below that.
Oh, okay.
Yes.
From here also you can access.
And you can get the path.
From here also you can access. That's it for today. Any question?
One more thing. If we set the runtime to GPU, that means all operations are being done in GPU, right? In Colab?
Yes. Yes. Like here. Here, like you can see that since I have changed the runtime to none, now it is giving CPU. Device equals to CUDA. If now this CUDA dot is available is false, so it is showing CPU. If I set it to GPU, then okay.
Okay.
So we can end this session now. That's all for today. You can leave.
Thank you.
Thank you.